Let's talk about the thing that most of us were taught to use with word problems and probably have taught ourselves. Keywords. Find the keywords, circle them, match them with an operation, and move on. And the hard thing with keywords is that they sometimes work. It's what makes them so dangerous. Because when students trust them, they stop thinking about the problem. And when the keywords don't work, they have no way to figure out the problem. Today, we're going to go through why keywords feel helpful, how they can quietly sabotage sense making, and what to do instead. Hi, I'm Michelle from Thinking Math Corner, and I help middle and high school math teachers build student thinkers through productive struggle, not memorization. Keywords offer certainty. When students see them, they automatically use them and match them up with an operation. There's no hesitation, no questioning. They feel like a safety net, especially for students who are struggling with word problems. The problem is that keywords only work when word problems are written to obey them. Real situations don't obey vocab lists. And the moment the word problems don't follow those vocab lists, students aren't working through the math, they're guessing. Here's the real problem. Keywords don't describe operations. They describe relationships. And relationships depend on what's changing, what's fixed, what we're trying to solve for. Let's look at what this would look like in some real classroom examples. A jug contains 18 liters of water. After pouring out some water, there's 11 liters left. How much water was poured out? Most students subtract. And in this situation, that's right. But it's not because of the word left that there were 11 liters left. It's because of what's happening in the situation, that we're taking some away from the initial amount. The operation matches the situation. Now let's look at a different problem. After giving some stickers away, Maria has 11 stickers left. How many stickers did Maria have at the beginning if she gave away 7? The same keyword appears, left. But subtraction isn't the operation that matches the situation. We're working backwards to find the starting amount. This is an addition situation. Same keyword, but different operation, different structure. The math didn't change because of the keyword. The math changed because of the change in situation. The math changed because of what was unknown. Here's another situation. Each notebook costs $4. If you buy 6 notebooks, how much would you pay? Multiplication fits. Equal groups, total cost. It's pretty straightforward. But let's look at another question. Each notebook costs $4. The total cost is $28. How many notebooks did you buy? Same keyword, but now multiplying gives you the wrong answer. The situation didn't change. We're still buying notebooks, but the question did. Now we're finding how many groups, how many equal groups fit into the total. This is division. The problem is keywords don't adjust for what's unknown. Thinking does. So picture this. A student is working on a more than problem. The student confidently says, it says more than, so I add it. They get an answer quickly, and it's wrong. When you ask them to explain, they point to the word, not the situation. There's no confusion, no hesitation, just certainty. Except it's wrong. And that's the red flag. The issue isn't carelessness or lack of math skills. It's about the trust that that student has in what a keyword will tell them about the situation, about the operation that they need. This is the moment to pause the class, not to correct the operation, but to review the situation, the understanding of what's happening. Who is being compared to whom? What's happening in the situation? Can you describe it? What are we looking for? What's the question asking? Let's look at another set of problems. The total number of students in 2 classes is 48. There are 25 students in one class. How many students are in the other class? Addition and subtraction naturally occur here. The word total suggests addition. A gym charges a sign-up fee of $30 plus $15 per month. The total cost of the membership after several months is $165. How many months has the member paid for? Students often try to add the numbers together because they see the word total. But this problem isn't looking for a single calculation. It's describing the relationship between the changing amount and the fixed amount. This leads to a linear equation, not just a keyword move. The pattern that's seen throughout all of these problems is that the keyword doesn't change. The keyword stays the same, but the operation changes based on the situation. The deciding factor is always the situation and the unknown, not the keyword. So then the question becomes, if keywords are not reliable, as determining what you need to do with the equation or with the numbers, what do we use? That's where our questioning techniques come into play. We start asking questions not about the number, but about the situation. Describe to me what's happening here. Draw a sketch to represent what's happening. Numbers become secondary. We need to look at the relationships. I might ask questions like, well, what's changing here? What's staying the same? What are we looking for? What's the unknown? What's happening in relationship to something else? Can you describe to me the situation without just reading the words? This moves students from translating the problem to interpreting the word problem. And that is so key. It's all about reasoning with relationships. So when students start to use keywords less and start relying more on the situation, there are a few actions that you'll see them take more frequently. They'll pause before calculating. They will draw a sketch to make sense of what's happening in the situation, what the pieces of information we have and what we don't have, what we're trying to find. They will round the answer appropriately depending on the situation. They'll ask if it makes sense. I have this negative number, but it's supposed to be money. Does that make sense in this situation? Can I get 3/10 of a can of paint? Those sorts of questions that they're asking themselves, those indicate that those students are sense making, not just translating and using keywords. They also start transferring that thinking to unique analysis type questions that they've never seen before. They use the same amount of strategy and understanding of the situation, but they're able to stretch that. At the end of the day, keywords promise speed, but getting the wrong answer faster is not the goal. The goal is to get the correct answer as efficiently as possible while understanding the situation. When we teach students to pause, interpret the situation, reason what's happening and what needs to be done, making sense and connections between numbers, that's when students start to soar. And that shift from reacting to words to making sense of the situation doesn't happen by accident. It needs structure. One of the things that I've developed is a think before you solve framework. And it's designed to be used in sense making with word problems. Inside my recent live Think Before You Solve Word Problems workshop, we explored how to realize what students are doing, how to diagnose it, and learning about how we encourage sense making with word problems, not by providing more strategies or providing more keyword lists, but by making that sense making and examining the relationship between what's happening in the word problem. The workshop is now available as a mini course. It's a highly valuable workshop. This mini course helps teachers to be able to diagnose what's happening with students in their classroom and give tangible strategies, that framework, that think before you solve framework, to be able to address the sense making as opposed to keyword dependence. You may want some background knowledge about how to interpret word problems and some strategies to use with that. And if you click the video on the screen, I'll be going through all the different ways that you can approach word problems in a way that fosters sense making.